Hello guys, welcome to Inside Electronics. So in today's episode we are going to take a look at this electronic doorbell. Now by saying this is an electronic doorbell, I mean this is not operated by your regular AC mains. You can see two wires right here, but that is not going to your AC mains outlet, but instead it uses batteries. So this is a DC operated doorbell, and these two wires, these are the switch wires. You short these two wires together and that is the switch for this doorbell. It also has an LED. The LED has something special to it because this is not glowing right now. This is just a reflection from the light from above. This LED actually lights up corresponding to the tone of the melody that this thing makes. You can actually watch that in the video that I made with this about all the different tunes in it. And to be started with, this thing has more than 15 different melodies built into it, and many of them are Hindi Bollywood songs. It has a switch over here that you can select between two different states of operation. On the position 1, which is down position, which is that right now, this thing keeps on repeating a single tone, which is just a basic tone. If you push the switch up, it will then change to a multi-melody doorbell, so that in this position when you press the switch, each time a different melody is going to be played back. So I'm going to show you that. Let me put some battery, but before that let me just tell you that this is made by GM. So this is not a cheap Chinese one. This is actually a quality component, and this is made in India itself. And as you can see, multi-tune bell with flashlight, patent pending, registered design. So this is the second product that I'm reviewing that is made by GM. The first product is this one, this electronic mosquito repeller. I made a review about this. I made a teardown of what's inside. You can watch it by clicking the I button which is in the top position. So let me show you. Let me just keep two batteries inside. Let me see if I have two batteries. I don't have double A's right now, but I do have triple A's lying around. These two batteries lying around. I hope may fit. Oops, they're not. They don't fit, but let's modify. Let's just make it fit by pulling the strings like that, so it extends to some extent like that. Now let me see if I can make it. Yes, that really has done the job. May not be perfect. Yep, it may not be perfect, but you got the idea. Now please keep your volume low for this, okay? I'm just going to short it. It may sound loud.
Open the door, please.
So that is a default melody, and if I switch to the other mode, you can see that if I short, okay, that is the default melody. This is the default melody. So if I switch to other position, you can see so that's it. If I switch to the other mode, I'm not going to play all the songs because this thing has like 20 melodies built into it. I think, yeah, 20 something melodies. I will make a separate video just for those melodies playing around. So the interesting thing about this thing is, let's open it. There are some possibilities. This is actually a used one. This is not a brand new unit. And for some reason, if a person cannot actually determine whether this is a DC one, what is going to happen is that, just like usual, he's going to plug these two wires into the AC mains unit. And by the way, it uses the flathead. It's been a very long time since I used my flathead screwdriver, because usually nowadays all of the electronic devices use this Phillips head screws, like that one. Yeah, it's not focusing, but you got the point. So let's open it. Yeah, so what I was talking, this There is a possibility for someone who doesn't know much about these electronic things. He may find, if, especially when the cover is closed like that, and say it was lying like that, so he may try to poke these two wires into the AC mains outlet, and that will be the end of story. Then we have one more left. So I will definitely make another video and I will link it with this video using a card at the end, so that you can watch or you can listen to all the melodies. So I hope you notice the LED glowing in respect to the tone made by the speaker. If you haven't watched that, you can watch on the other video. But let's see. That's the speaker. So this is a regular speaker up there. Let me focus on it. So this is just a regular speaker. So since this is an electronic version, let me just zoom down. Since it's an electronic version, you may not expect the mechanical parts in it, and it has a few other circuit boards. That's a switch where you change the default tone or to the multi-mode option. So let me just, so that's it. That's the bare minimum of that thing right there. So these, so just I'm going to pause for now, and I will be back once I just try to reverse engineer this and see how it works. Yeah, so guys, I have completely reverse engineered the circuit. It is really simple, and in fact you can divide this whole circuit into two sections, the audio section and the visual section for this LED. So up to this point where my finger right now is, to the left of is what the audio section is comprised of, which is this LY920. This is the heart of this entire doorbell, which is the audio making thing. And towards the right side is what? From this transistor, towards the right side is what the visual section is consist of, which means the entire section is used just for the sake of lighting up the LED. So I have drawn a schematic for this, and this is the schematic for this entire circuit. So the schematic also, we can divide this into two sections. For, let this be the center line. So what is in the left of this is the entire audio section, and what is in the right is the visual section. So as you can see, I have drawn two switches. One is the melody and mono selection, which is this one, and this is a switch which activates the alarm, I mean the bell, which is these two wires over here. So this is actually pretty much self-explanatory because there is nothing much into it. As I mentioned earlier, this LY9208 is the heart of entire operation, and this is a custom made chip because there is no information available in the internet about this LY9208. There are results, a lot of results when you search for it, but nothing is relevant because everything is related to power converters and things like that. I have searched for all combinations. So if you have any idea what that chip might be, please give me a link in the comment section to this device. So let's begin with the left side, which is the audio section. This can either be a microcontroller or it can be a dedicated audio IC. Either way, it is a 14-pin device, but only 6 of them is used, and out of the 6, 3 of them are used for power. As you can see, pin number 3, 12 and 11 are for the power, and 4, 5 and 9, these 3 pins are used for the sound purpose. And as you can see, the pin number 4 is the output, which is amplified by this simple transistor amplifier. This is a direct connection. There is no feedback and no current limit. It's a direct application, and considering the voltage is only 3 volt and you are going to use standard carbon battery, not these any loop, high current any loops or things. This is just for test purpose. I used any loops, but what you are using is only the regular 3 volt carbon batteries. The current will not be a factor to be considered because the internal resistance itself will limit the current through it, I hope at least. So This is an NPN transistor, so under normal cases this will be turned off, and because it is turned off, the speaker cannot be connected to ground. So whenever there is an output, it will turn on this transistor, and the transistor turns on, and the speaker will get connected to ground, which makes a sound which will be equivalent to whatever the voltage that is coming from pin number 4. And the pin number 5 and 9, I don't know how the internal of this thing works, because without knowing the chip we cannot reverse engineer what's happening inside it. But on the other side, it is actually it switches between melody and mono by connecting the appropriate pin to VCC, and for that purpose is what this transistor is used, and that is what this transistor right here. And by the way, this transistor is this one over here, and right now this switching transistor is this one. So what happens is that this is a PNP transistor. So under normal cases, this base of the transistor will be pulled up to the VCC, which makes it turns off, which makes it off, and thereby nothing comes out of this pin number 4. So when you pull it, when you short circuit the switch, you're actually pulling the base of this transistor towards the ground, which will turn it on, and depending on the position of this switch, the VCC will flow either to pin number 9 or to pin number 5, which will then somehow internally selects between the two different memory chips and provide an output. So that is the audio section completed. Now let's move on to the visual section. So as I mentioned, the LED lights up according to the sound that is made by the speaker. That indicates the speaker and the LED is somehow connected together, and that's why this circuit is used here. These are the two transistors. These are the two transistors that are drawn over here. One of them is a PNP transistor, and the other one is an NPN transistor. So as you can guess already, under normal conditions, this my camera is a little bit on the floppy side. Under normal conditions, this PNP transistor will be kept high, because if you notice, the base of this transistor is pulled up to VCC using this 1K resistor. At the same time, it is also connected to the collector of this transistor over here. So what happens is that when this transistor is off, there is no way the current can flow through this, and also since the speaker is connected to VCC, the current will not flow through that path, so it can only flow through the collector to the emitter. And when this transistor is off, it cannot make that happen, which means that the base of this transistor is connected to VCC. And because it's a PNP transistor, connecting the base to the VCC makes it off. And when that transistor is turned off, the current cannot flow through the collector and to the base of this NPN transistor. Since this is an NPN transistor, it needs a positive supply on its base to turn on. Right now, this transistor is turned off, so no current can flow through here to here, and that means this transistor is off, and thereby the LED will not light up. And let's assume that a sound is playing through the speaker. That means this transistor is turned on. And because this transistor is turned on, the speaker will get connected to ground, which makes a sound, and also at the same time, the base of this transistor can now be connected to ground through this low resistance path over here. And then what happens is that when the base is connected to ground, this PNP transistor turns on. And when this transistor turns on, the current can flow through the collector, through the emitter, to the base of this other transistor, which will then make this turn on. When this transistor is turned on, the current can flow through the LED, to the collector, to the ground, which will then turn on the LED. So overall, only if the speaker works, the transistor activates the other transistor, which will then activate the LED. So it's all connected together. That's the reason why the LED lights up according to the sound made by the speaker. So that is pretty much the entire circuit. That's really simple circuit, and this capacitor right here is for debouncing the switch, and that's pretty much it. That's the entire GM electronic doorbell reverse engineered. And by the way, this is a really long video because I have to reverse engineer it, I have to explain it with the circuit. And by the way, you can actually expect more of these schematic based reverse engineered videos in my channel coming soon. And also I will put an end card where you can watch the entire melody stored inside this chip. Also, by pressing the I button you can listen to that. So I hope you guys got an idea about how this thing works. Even though it's a really simple device, it takes so long to explain everything and to make it complete. So I hope you enjoyed. If so, please consider subscribing, watch my other videos, and thanks for watching. See you in another videos.